Welcome back. In this video, I'll be walking you through problems on differential calculus. This is Further Solutions Academy. Further Solutions Academy. Subscribe, share our video. Thanks. Okay. In this video, I'll be walking you through problems on differential calculus. This is number 1. Differentiate the following. Having sine inverse of x, cos inverse of x, and tan inverse of x. I want to differentiate this. Now, solution to this problem. Now, I have sine inverse of x. Now, I can easily write this as y equals to sine inverse of x. I can write it as y equals to sine inverse of x. I can also say that y equals to x all over sine. Now, with the help of my indices, if I have x raised to power y equal, let me use m raised to power minus 1, same thing as 1 all over what? M. The same thing here. Now, this can now be what? Sine y equals to x. I cross multiply. By cross multiply, I will have this. Now, I can now differentiate now. This is what? This is y, this is x. It means my x is independent. My y is independent while my x is dependent. Now, if I'm to differentiate now, I will have cos y dy dx equals to 1. Now, I can now divide both sides by what? Divide both sides by cos y, which I have y dy dx equals to 1 all over cos y. Now, I can now proceed by having, I can now have something like this. Okay, I can now proceed. If I have this, I can now say that what? Back to our trigonometry. Our trigonometry let us to know trigonometry ratio. Let us to know the logic behind this, which is with the help of my Pythagorean theorem. So Katwa. Now, Pythagorean theorem can tell me that this is 1, this is what? Y, this is x. Now, it means my cos x, it will be what? 1 equals to x squared plus y squared. Now, y equals to x squared plus what? Y squared. Now, I can also say that what? With this, if I have an angle here, if I have angle theta here, I can also have something like sine theta. It will be what? Y all over 1. It means, therefore, my y equals to sine theta. And also, if I have this, I can also call it what? Cos theta equals to x all over 1. Therefore, it means my x equals to cos theta. By so doing that, I can say that what? My 1 equals to what? Cos square x, cos square theta plus sine square theta. Now, I can use this as what? If I have that kind of things, this is from our Pythagorean theorem. I can have that. Now, I can also say that what? My cos square x cos theta equals to 1 minus sine square theta. Now, but what am I working towards? I'm working towards sine and y, cos y. I'm working towards cos y. I can now say that what? My cos y equals to what? 1 minus sine square y. Now, can I square root the both sides? If I square root the both sides, I will have this, we cancel this. Cos y equals to root of 1 minus sine square y. Sine square y. Now, for me to have that, I can now say that my cos y, this is my what? Cos y. What is my cos? Okay, I can now say that what? My sine y. Sorry, I'm working towards sine y. It means if I'm working towards sine y, I can now say that what? My sine y equals to root of 1 minus cos y square. The same thing. Now, back here now, I have my sine y here equals to x, which I have my sine y, equals to root of 1 minus x square. Now, this is equals to that. This is equals to what? This is equals to, I have this, I have this. Now, with the help of these two now, I can do anything I want to do now. What is my sine y? This is my sine y. Now, this is my what? Sine y. This is my sine y. Sine y is equals to x. Now, it means my sine y equals to x. It means from here now, from here, I can answer that what? Dy dx. Sorry, this one is just cos y. I don't need this, sorry. I don't need this. Okay. My dy dx equals to, my dy dx equals to, now 1 divided by, now what is my sine y? My sine y is equals to what? Is equals to x. My sine y is equals to x, which is now my cos y is everything that is here, which is what? Cos y. My cos y. Now, what is my cos y? This is my cos y, which is, I have this. I now have dy dx is to be equals to 1 divided by root of 1, which is 1. My sine y is equals to what? X. Sine y is equals to what? Minus x squared. That is my final answer. That is my final answer. Now, that is my final answer. Okay, this is number 1. Now, number 2. What I just need is these two. I won't rub that part up. I need that to generate the second one. Okay, this is my final answer for the second one. For the first one. Now, okay, let's bracket this. These are our key points. Now, the same way, if I have the one of cos, now I have y equals to what? Cos inverse of x, which I can also say that what? My cos y equals to what? X, with what we have done in the first one, which is number 2 now. Now, if I have this, if I should differentiate, I will have minus sine y dy dx equals to 1. Equals to 1. Now, if I should divide, I will have minus equals to 1 all over minus sine y. Minus sine y. Now, what is my sine y? My sine y is this. This is my sine y. It means I can now say that what? My sine y is equals to what is there. Now, dy dx, it will be equals to 1 divided by minus root of 1 minus cos square y. 1 minus cos square y. Now, by having that, what is my cos y? This is my cos y. I can answer what? Dy dx. It will be equals to 1 all over minus root of 1 minus x squared. That is my final answer. That is my final answer for the second one. Now, for the third one, for the number 3, which is question 3, the one of tan inverse. Now, my tan inverse, the same way. Now, my tan inverse is, I can say that y equals to what? Tan inverse of x. Tan inverse of x. Now, I can say that what? My tan y equals to what? X. If I differentiate my tan, I will have sec square y dy dx equals to 1. Now, I have what? Y all over what? The x equals to 1 divided by sec square y. Now, at this point, do I have sec? No. I can just move on to this part, which I have my sine square y plus cos square y equals to 1. If I have that, how do I derive sec? Sec is 1 inverse of, 1 all over cos. Now, I can divide all through by what? By cos, cos y, and cos y. Now, which I have tan. From that, my tan is equals to what? Sine all over cos. Tan square y plus 1 equals to what? Equals to sec square y. Now, sec square y. By so doing that, therefore, my problem is what? Half solved. I can answer that what? Dy dx, it will be equals to 1 all over tan square y plus 1. Tan square y plus 1, which I will have dy dx equals to 1 all divided by, which is, what is my tan? My tan is what? X squared plus 1. That is my final answer. Now, try this. Drop your comment after. Try this. Drop your comment after. Try this. Drop your comment after. The first one is sec inverse of x. The second one is cos inverse of x. And the last one is cosec inverse of x. Try this, drop your comment. Now, problem number 2. Problem number 2. I want to differentiate these particular problems. Now, differentiate the following functions. 1. The first one is y equals to (2x) all divided by cos 2x. The second one is 4 x raised to the power 5 exponential e cos x tan square x. And the last one is cos x powering sine x plus sine x powering cos x. Now, I want to differentiate these 3 problems. I have the first one, the second one, and the third one. Now, how do I solve this particular problem? Solution. Now, I can solve this problem. Yeah, I can use my approach of product rule, but it will be very long if I use product rule or chain quotient rule here. It will be very, very long for me to do that. And this one is likely I will hang. Now, it means I can solve this problem using limb approach. Now, if I want to use limb approach, I will have y equals to what? E raised to power sine x all over what? Cos 2x. Now, I can lean the both sides. If I lean the both sides, I will lean y equals to lean bracket of what? E raised to power sine x all over cos 2x. Now, for me to have this type of something, if I have lean, my lean the same thing as log in what? Okay, I have x. This, they are the same thing. They are the same thing, which is I'm working towards what? Logarithm. Now, if I'm not very good in logarithm, I don't have laws of logarithm here, there will be a problem. Now, with the law of logarithm, I can say that what? Ln y equals to what? Ln e raised to power sine x, which is exponential power of what? X minus ln cos 2x. Now, at this point, I can say that what? Ln y equals to sine x ln e equal minus ln cos 2x. Now, if I have ln like this, same thing as what? Log exponential e. If I now have this, I have this, which is equals to what? 1. If it's equals to 1. Now, if I have the same base and the base and the numbers are the same, it means it's equals to 1. Example, log 10. Log 10. It means log 10 into what? That 10 is in base 10 is equals to 1. You can try a calculator or any device. Now, if I have this, I can now say that what? Ln y equals to sine x minus what? Ln cos 2x. Now, how do I solve this now? If I want to differentiate this, is an independent function, which is what? Y, 1 all over y. If I differentiate ln is 1 all over, attached with what? Dy dx equals to, this one I will have cos x minus, I will have minus. If I should differentiate this, now, this is function of what? Of a function. Now, I can hold on to, okay, let's just say let u equals to what? Cos 2x. Which I differentiate this, u prime is equals to what? Is equals to minus sine 2 sine x. Now, differentiate the ln itself. Y equals to what? Or m equals to ln u. If I have m prime, it means my m prime is equals to 1 all over u. Now, it means the whole function of this, it means what? My m prime, it will be, okay, if I differentiate my m now, it will be what? Minus 2x all divided by what? What is my u? This is my u. Cos what? 2x. That is function of what? Function. That is our last video. From our last video, you get the logic behind this. Now, I want to do this. I will hold one, which is, if I differentiate this, I will have 2 sine 2x minus, okay, divided by, if I will repeat this, which is cos 2x. Cos 2x. Now, my final answer will now be what? I can now cross multiply. I can multiply both sides by y. This will cancel this. It means I have dy equals to dy dx equals to, I have cos x plus 2 sine. Now, sine all over cos, they are of the same argument. Now it can give me what? It will give me tan 2x. Now what is my y? My y is here, which is when I multiply both sides. My y is, I can bracket it, my y is equals to what? 2 e raised to power sine x, 2x, e raised to power x divided by what? Divided by cos 2x. Now, I can now present my answer this way. All over x equals to what? E sine x bracket of cos x plus 2 tan 2x divided by cos 2x. That is my final answer. That is my final answer, which is number 1. Now, number 2. Number 2. Number 2, I have something like okay, that my number 2, I have something like y equals to 4x raised to power 5 e raised to power cos x tan 2x. Now, how do I solve this particular problem? I can also use the ln the both sides. I have ln y equals to what? Ln bracket of 4x raised to power 5 exponential cos x tan square x. Now, at this point, I can now use my what? Log 1 of my what? Logarithm. Log 1 of my logarithm. I have ln y equals to ln 4 plus ln exponential cos x plus ln tan 2x. Now, with help of this, now I can now say that what? Ln y equals to what? I can have ln 4x5 plus cos. This my ln, cos will come down. Normally we have ln e plus 2 ln tan x. Now I drop all the powers, I drop them down. Now this one become what? This one become 1, which I have ln y equals to what? Ln 4x raised to power 5 plus cos x plus 2 ln tan x. Now I can now differentiate. Now if I should differentiate, I will have 1 over y dy the x equals to, if I should differentiate that part, which I will have, differentiate this. Okay, if I should differentiate this, I will have 20 x raised to power 4 divided by 4x raised to power 5. 4x raised to power 5. Plus, if I should differentiate this, I will have minus sine x. Now, plus this one, if I should differentiate ln tan, now I will surely have 2. Now, differentiate tan, I will have sec square x divided by what? Tan x. Tan x. Now, it means, what is my sec? Normally, my sec is equals to my sec x is always equals to 1 all over cos x. Now, if that is the case, I can now express this as I want. I can say that what? My dy dx equals to this here, okay, this here will be 1, 1, here 1, here 5. Now, I can say that what? 5 all over x, 5 all over x, okay, 5 all over here. This one will cancel, which is remaining 1 here. Now, this one will be minus, now, minus sine x. Now, this one, I can now plus Now, my square x, normally I can express it as what? I can express it as, let me open a bracket here. What is my sec? I have 1 all over what? Cos square x divided by, what is my tan? My tan is what? Sine x all over cos x, which also I can rewrite this as multiplied by, I have cos x all over sine x. This square will cancel one of the. Now, it remains only one cos. Now, I can answer that what? Dy dx equals to 5 all over x bracket of y. Bracket of y. Because I've multiplied both sides by what? By x from here. Now, I can answer that what? 1 over minus sine x plus. Now, I can now say that 1 over cos is what? Sec x. 1 over tan is what? Cosec x. Now, close your bracket. What is my y? My y is 4x raised to the power 5 e raised to the power cos x and tan square x. That is my final answer. That is my final answer. Now, the third one. The third one. I have y equals to cos x raised to the power sine x plus sine x power of what? Cos x. Okay, if I have this type of problem, I can see that let y equals to u plus v. U plus v. Now, hence, my u equals to what? Cos x raised to the power what? Sine x. If I have ln here now, if I should apply ln here, now let's call this one equation 1. Now, if I should apply ln here, I will have ln u equals to sine x ln cos x. Now, this is a product. Now, if I should differentiate this, I will have 1 all over u dy du all over the x equals to. Now, I want to hold this, differentiate this. If I should hold this and differentiate this, I will have sine x. If I want to differentiate this, now my cos will be what? It will turn to minus sine x after differentiate divided by what? Cos x. Now I open the bracket, I close the bracket, plus is a product rule. Now I will hold this, I will differentiate this and hold this. If I differentiate this, I will have cos x and what? Ln. Now, which is that? Now, after that, I can answer that what? This and this, is there anything that can come up? Yes. I can turn it to what? 1 all over u du dx. It can be equals to, this one will be, I can turn it to cos x ln cos x. Also, minus, the same thing here will be minus, I have sine x tan x. That is for my u, which if I should multiply both sides by u will cancel u. Now, my final answer will now be what? Du dx. It will be equals to cos x ln cos x minus sine x tan x bracket of, what is my u? This is my u. Cos x close the bracket of what? Sine x. That is for that my u. And for my, now for my v, I will do the same, which I have v equals to what? Sine x bracket of cos x. Now I will have d 1 all over v dv dx. It will be equals to 1 all over v dv dx. It will be equals to, okay, before we do that, which also implies, I have cos x ln sine x. Let me do that one like this. This can also implies that if I after ln, now I'm coming from my u. Now I can also, when I differentiate this, if I differentiate this, I will have cos x multiplied by, now differentiate, I have cos divided by what? Sine x, plus, if I differentiate this, I will have minus sine x, which is everything here will be minus sine x ln sine x, which I will now have this, and this is going to be what? Cot. Now I can now say that what? Dv dx, it will be equals to sine x cot x minus sine x ln sine x bracket of, what is my v? My v is given as what? Sine x raised to power cos x. Now that is my v. Now my final answer, which is what? Du dy dx will be equals to du dx plus dv dx. Now I will now put, which I will have dy dx will now be equals to, what is my dv du dx? I have cos x ln cos x minus, I have sine x tan x close to bracket of cos x bracket of sine x plus, now I have cos x cot x minus sine x ln sine x close the bracket of, I have sine x bracket of what? Cos x. That is my final answer. Okay, you can try this. That is solution, answer to question number 3. Now you can try this. Drop your comments after attempt. Okay. Drop your comment after attempt. The first one is, okay, if I have okay, let me just give you 1 or 2. Let me try to give 1 or 2. Okay, let us work on, okay, let me just give something like very simple that won't cause any issue. Okay, I have okay, if I have y equals to e raised to power times x square divided by plus x. And number two, if I have y equals to x squared e raised to power cos x divided by sine x plus 1 square. Try this and drop your comment. But limitation of this lim is that anytime you are asked to differentiate and there is a lim, you have maybe something like this: y equals to lim something x whatever, and you are asked to differentiate this type of question. It's not advisable to use it. This is Further Solution Academy. Further Solutions Academy. Please share, subscribe our videos. Share and subscribe to our video. Thanks.